don't do for simple structure like beam, etc. So before we do, we give a concluding remark of the stress tensor. Although the component of stress at a point are vectorial in nature, they are not ordinary vectors. Mathematically, they do not obey the laws of vector addition and subtraction. These stresses are vectors of higher order because in addition to having a magnitude and sense, they are associated with unit area. As you change the plane BV, you have seen normal and shear stress having infinite combination. So therefore, the basic problem is solved by first converting the stress to force, multiplying with the area that you have seen in the case of algebraic sum the moment of the forces equal to 0. And we get complementary shear stress quantities. So therefore, these vectors are consequently can be added or subtracted. We give example in the next and we define what simplification we do for engineering problems. The first simplification will be the plane stress situation. And along with this, we'll also find out the stress transformation equation later on. In this diagram, figure A thin plate is loaded to forces applied at the boundary. You can see the cross section. And another one, a beam simply supported, subjected to uniformly distributed load on the top of the beam. You can see all over. In these cases, direction Z will have this plane, and we assume that normal stress sigma ZZ, shear stress tau XZ, and tau YZ is not available, that is 0. On the both plane of the beam as well as on the plate, and it may be assumed tentatively that they are 0 within the plate or the beam. Therefore, the state of stress will be restricted to by two normal, sigma xx, sigma yy, and tau xy. And this is called the plane stress situation. So this is the definition. So a question comes, discuss plane stress situation with engineering examples. To understand it better, how the stresses will be shown in matrix, I take the previous one. In this case, the quantity that is not existing for plane stress, you write it here. I cannot write for you. This is 0.
Yes, sir.
This is 0. This is 0. This is 0.
ये वो सिचुएशन उसमें 0 होता है.
Okay. You write on your paper sigma ij equal to sigma ji for plane stress, 2 normal and 1 tangential, 3 component. Right? So these are not figurative. You write for plane stress sigma xx, sigma yy, and shear tau xy. Zero you are not right. It is already 0. You have written. So for plane stress, 2 normal and 1 tangential. You write. Okay. So you will be having 2 normal and 1 tangential for plane stress situation. How it is going to be presented on a beam? You have written all of you? Okay. Now let us take an element. Let you draw the beam. This is the element, okay? On this element, the stresses are to be shown that we have written on the matrix, sigma ij. How it can be shown? In the direction of x, I give sigma x. In the direction of y, in the direction of y again, all of you draw the normal stress. In addition to that, you are going to have the shear stresses. The complementary will come on the top and bottom, but because this space is very small, it will be making more complicated. Plus, you do it on your paper. The beam end you draw, element you draw. This is very small, but in the laboratory you can do this type of experiment, and when the subject is in progress, we will show you how to calculate normal stresses, sigma x, and how to calculate shear stress, tau xy. In the beginning of the course, which is elementary, we neglect sigma y when we discuss the normal stress in beams. Very quickly we will come to the, it is already given to your site, you can download and you can read it, but the sigma y quantity we will not be taking for undergraduate, for postgraduate we take the sigma y. That we will discuss separately. But this you have understood or not? There is a beam, we take a point, we draw two-dimensional element, and over the element, normal stress means normal to the plane, shear stress means tangential to the plane. Yes. Is it clear to all of you or not? How we are going to get an element? Okay? Any question on this? How we are drawing the element? These two are normal stresses and shear stresses. Now, the whole thing that is been drawn, yes. It is an assumption that the quantity on z plane, that is this plane and this plane, we assume they are not existing. Simplification. In engineering practice, many things we consider not existing. Really, it will not be existing when you do experiment. Okay? So, we will be getting only the three, two normal and one tangential. That you have seen in your matrix, that is here. These are zeros. These two and one tangential will be there. And you write this three in the matrix form. Okay? Now, taking this figure that has been drawn today on the transparency.
So this is the same as we have drawn the rectangular two-dimensional structure 2 slides before.
Yeah, that's right. So this simplification will come and we will be utilizing it further. Now what is the importance, I will tell you, next slide.
So you have not drawn the tangential stress on y direction.
Okay, I have drawn it with giving dimension of the element. Delta x in x direction, delta y in y direction, having the quantity A is identified by A, B, which is normal to x direction, A, D or B, C, normal to y direction. X direction will have sigma x. I am eliminating double subscript here. Because we have understood sigma x means normal to x plane. Okay, sigma y means normal to y plane. So why to write double subscript? We economize in writing and making less of confusion. These three quantities, sigma x, sigma y and tau xy, we can determine. How we can determine? We are not going to exercise now. At this moment, we say it is given to you, or we can determine by experiments, by many methods. At this moment, this is given to you engineers are not satisfied by merely knowing two normal and one tangential. What they do, they don't have to do that quantity. They always look one quantity, which is maximum, where is maximum, and second quantity, which is minimum, where it is minimum. Why it is required? Why they go for maximum, why they go for minimum? Because that is the process by which you can design a structure. A maximum one which is coming to a particular point has to be taken proper care by designing that it should not fail in our service life. The minimum one is required to be known because we should economy in the giving the material for that minimum. We don't require so much of material for minimum stress. So therefore, engineers is always looking for where is maximum and how much it is maximum and minimum. Okay, it is very important. And it is very simple to understand. It is very, very simple to understand where it is maximum and where it is minimum. That's why we find out in bending moment diagram and shear force diagram maximum bending moment, zero bending moment, maximum shear force, zero shear force. Is it clear?
Yes.
Now, to obtain that, nothing is written from the given, but everything is available from the given data. What is that? We do not know where it is available. We draw a plane. This plane is a new plane, anti-clockwise direction theta, AC prime. And over this plane, we represent normal and tangential component. Normal is sigma x prime and tangential is tau x prime y prime. These two quantities can be determined from the known given data. Right? So you write down here the given data, otherwise you will not be able to follow it.
सिग्मा एक्स
ये सर ने गलत दिखाया है सिग्मा वाई एक्स
क्या
वो तो सही है टाउ एक्स वाई सही है टाउ वाई एक्स ये वाला
You write down here
बोल सर
क्या
these data.
ये जो ऊपर से एरो आ रही है टाउ एक्स वाई इधर से आई है टाउ वाई एक्स वन इधर से एरो इससे
You write here given.
सही लिखा है
I have encircled.
ऐसे लिखा
वो वाला
Draw
same
this
था।
diagram. AB plane, BC plane, and it is given.
तो बोल देगा ही नहीं
Write down. Otherwise, you will not be able to
सर ये
remember.
टाउ वाई एक्स होगा ना तो इस साइड जो है
Tau x y. So we are considering is downward.
नहीं सर इस साइड से बोल रहा हूँ सर
This is tau
हाँ
x.
हाँ टाउ वाई एक्स
That has
Yeah.
been complemented. Yx is changed to xy.
एक ही तो बात है वो जेड आई और आएगी
नहीं सर मैं वो तो सर इस साइड
This
डायरेक्शन
is
में
xy. This is also xy. They are complementary in nature. The moment coming here, clockwise and anti-clockwise must be same. Okay.
सर दिस वन इज टाउ एक्स वाई प्राइम
Yeah, these two are unknown. This is normal stress, sigma x prime, and this is tau x prime, y prime. On a new plane, theta anti-clockwise. We consider theta anti-clockwise positive. Now from this diagram, which is a right angle triangle, if A to B distance delta y is
ये
given,
समझ में नहीं आया टाउ एक्स वाई
draw this right angle triangle.
वो तो सी डैश मान लिया कोई भी नीचे
From the right
टाउ
angle
वाई
triangle,
ऊपर ही मान लिया
if
डैश
A to B distance is delta y, can we find out what will be BC prime and what will be AC prime from trigonometry? The angle is theta here. This is your perpendicular, this is your base. So you can see here that BC prime and AC prime, it is hypotenuse. This is your base of the triangle and this is the perpendicular of the triangle. So how to find out? BC prime will be AB is T, thickness is small t, AB is delta y, AC prime will be AB sec theta, and BC prime will be AB tan theta. Any question on this? So we have come to know the given quantity and we have come to know that what will be the dimension of the triangle if one side A to B is given.
सर ये थीटा माइनस ACW का भी है नीचे
It
फॉर
is
ऑल
not minus. Theta anti-clockwise positive. I can put arrow here. It is not negative. Theta anti-clockwise positive.
पॉजिटिव
If it is clockwise, we will consider negative. This is for one. Is it clear on this diagram? Just concentrate on this diagram.